Okay, so in this question, we want to use horizontal rectangles to find the area bounded by these two curves. So we want to find out what is this area in between them, which is this area right here. Okay, so finding this area, the reason why I want to use horizontal representation of rectangles here is because if I was to draw a vertical rectangle here, unfortunately the top and the bottom curve are the same. Now I know over here your top curve is a different curve than your bottom curve, but it's not consistent throughout this whole area. Meaning it starts to become a problem when you look at this part of the graph. Okay, so we're going to use horizontal representation because if I do that, if I draw a horizontal rectangle, everywhere I do that, notice that my right curve is always this dotted curve and my left curve will always become this linear graph. So my right curve is unique and my left curve, it will always be unique as well. So horizontal representation is the way to go. But when we're doing horizontal representation, we're integrating very differently. We're actually looking at a y1, y2 values. So my upper and lower limits are actually on the y-axis this time, not on the x-axis. And I'm looking at right curve minus left curve, right minus left. And not only that, but I'm actually integrating with respect to y. So everything needs to be rewritten in terms of y instead of x. So when I look at my curve, notice the first curve, which happens to be my right curve, okay, my right curve, ends up, I actually isolated the x value already. So 3 minus y squared can stay the same. When I look at the left curve, however, notice that y is isolated, but I want to isolate x instead, because I want everything in terms of y. So I get y plus 1 is equal to x, and so that's my left curve. Okay, so everything is good there in that part. Now, what is my y1 and y2 value, though? I mean, where are these two graphs intersecting? Because this bottom intersection is going to give us y1. This top intersection is going to give us y2. So I actually need to find these two values. So that is an intersection point between the two graphs. So I'm going to find the intersection point between two graphs, I have to set these graphs equal to each other. So I'm going to take x minus, I'm going to write it out over here, x is equal to 3 minus y squared, and now I have x is equal to y plus 1, and I'm going to set these equal to each other. So 3 minus y squared is equal to y plus 1. Okay, so when I look at this equation, it's going to end up being quadratic. So I'm going to bring everything to the right-hand side. So I get 0 is equal to y, positive y squared, and then I get positive y, and then 1 minus 3 is going to end up giving me negative 2. So I need to PSA factor this. Okay, so product, sum, answer. My product is going to be negative 2. My sum is equal to 1. So my two numbers should be 1 and 2, where the 1 is actually negative. So because my a value is 1, I can go right into my factors. I get y minus 1 and y plus 2. So these are going to give me my intersection points. They intersect when y is equal to 1 and when y is equal to negative 2. So what makes sense here is that y1 should be negative 2 because it's a smaller value, and y2, which is my upper limit, should be positive 1. Okay, so now that we know where they cross each other, we can set up the integral. So my area is equal to y1, which is the small number, negative 2 to positive 1. My right curve, okay, my right curve is defined by this function. So I'm going to put in 3 minus y squared, and then I'm going to subtract my, my left curve. So my left curve was redefined as y plus 1. So I'm going to put that in my function. So minus y plus 1. And we're integrating all of this with respect to y this time. So you see how everything is in terms of y, not x anymore. So now we can actually integrate. So my area is, actually, you know, I'm going to simplify this. So I'm going to go area is equal to negative 2, from negative 2 to 1 is, I have 3 minus y squared, oops, then minus y, then minus 1, so we're subtracting all of those terms, and then I'm going to collect my like terms. So a is equal to negative 2 to 1. My like terms, the only ones I have here is 3 minus 1, so if I rewrite it in order here, I get negative y squared minus y, and then 3 minus 1 will give you positive 2. Okay, so we're integrating once again with respect to y. So I think we're ready to integrate now and find this area. So we have negative y to the power of 3 over 3, then minus y squared divided by 2, and then plus 2y, and then we're going from negative 2 to 1. Okay, so now we're going to evaluate the integral. So area is equal to, putting in our numbers, we start with 1. So 1 cubed over 3 minus 1 squared over 2 plus 2 times 1. Then we're going to subtract all of this. So negative of the negative 2 cubed, so careful with those signs, and then minus negative 2 squared divided by 2 plus negative 2. Okay, so I have to be careful here with the evaluation. So I'm just going to go through each one here. So negative 1 cubed is over 3 will give us negative 1 over 3. And 1 squared will give us positive 1. We have a negative in front, so minus 1/2 plus 2. Then minus, so inside the brackets we have negative 2 cubed, which is negative 8, so it becomes positive 8. So I'll just go 8 over 3. Then minus negative 2 squared gives us 4. And then 4 over 2 will just give us, well, I'll go 4 over 2 for now. And then plus and negative 2 will give us minus 2. Okay, so we're almost there. We just need to bring everything together here. Okay, so just, oh, you know what? I just realized this is negative 2 times positive 2. So there should be a positive 2 in here. So negative 2 times 2 will give us negative 4. So sorry, this should be negative 4 right here. And then, so I think we're good to go. We're just going to go ahead and bring what we can together. So first of all, I'm going to actually get rid of these square brackets. So when I do that, oops, I get negative 1 cubed minus 1/2 plus 2, and then I get negative 8 over 3 plus 4 over 2, and then plus positive 4. So I just changed all the signs there. So putting all my like terms together, I'm going to get area is equal to negative 9 over 3, and then the halves can go together, so I get positive 3 over 2. Positive 3 over 2. And then I have 2 plus 4, which is going to give us 2 plus 4 here is going to give us 6. Okay, so all in all, when I put all these numbers together, what I'm going to get is 9 over 2 as my final answer.